go. Okay, so let's take a look at the first 9 problems of this practice for quiz 3 that's coming up. So let's see, we got tert butoxide plus ketone. This is acetone, gives you tert butanol plus the conjugate base of acetone. So which one is functioning as an acid? Would it be 1 or 2? Which one is donating a proton in this case? Could anybody identify the acid? Would it be 1 or 2? Yeah, thanks, Sarah. It's 2. It's donating a proton, right? So you can say that the base is going to grab this proton like this. So 2 is going to be the acid, 1 is the base. Right, and if we were to label these, this is the conjugate acid, and this is our conjugate base. All right, the next question is important. It says, because it says, draw the conjugate acid of this ether, right? You have an R group, and then an oxygen, then another R group. So if we draw the Lewis structure, the important thing that you understand here, if you haven't noticed yet today, the difference between an acid and its conjugate base, or any base and its conjugate acid, is 1 H+ ion. So if this is the base, all we have to do is add 1 H+ ion to it, and we end up with the conjugate acid. Right? That's it. All right, the next one says draw the conjugate acid of the following compound. Again, what's the difference between a base and its conjugate acid? It's 1 H+ ion, and so we're going to add H+. Well, where is it going to go? It's going to go on the oxygen, right? Because we have lone pairs there. The same thing for this one. I could have drawn a curved arrow for it. So we're going to end up with an oxonium ion, like this. So we're going to have 3 bonds, 1 lone pair. So we have a +1 charge. Here we go. The next one says draw the conjugate base. So again, the difference between an acid and its conjugate base is the loss of 1 H+ ion. So if we redraw the compound like this, if you lose minus H+, what do you end up with? Well, the most acidic proton is the one attached to the sp hybridized carbon. And so this is the conjugate base that will result. Question number 5, what is the conjugate acid in the following reaction? Did anybody identify the conjugate acid? Is it 1, 2, 3, 4, or 5 in this one? So it's not going to be 3. Right, if we look at what's going on here, this guy is donating a proton. So this is our acid. Okay. This is our acid. And then this is our base. And so this is going to be our conjugate base. And this would be our conjugate acid. The water is the conjugate acid here. And so number 4, which is water, would be the conjugate acid. Somebody asked me if we had these kinds of questions, would we have different curved arrows leading to the same product? No, you have to have the same curved arrows to get the same product. There's only one way to draw the curved arrows correctly. There's not more than one way to do that. Okay, let's move on to question number 6. What is the conjugate acid in the following reaction? So you can see that you have an ammonium ion here. So this is going to be our acid. This will be our base. Therefore, this will be the conjugate base. And this would be the conjugate acid. Like that. So you could practice drawing your curved arrows here if you want. This is going to grab this proton and put the lone pair on here. So, Sean, the answer to your question is sure, I suppose. Yeah, you could be like choose from the correct curved arrows for sure. Let's move on to the next one. So label the acid, base, conjugate acid, and conjugate base. Well, we have an sp hybridized carbon with a hydrogen attached to it. And then we have the hydroxide ion. I'm going to redraw that. And so that's going to rip the proton off of the alkyne. And so we end up with a lone pair here. So that means that the alkyne would be our acid. The hydroxide would be our base. This would be our conjugate base. And this would be our conjugate acid. Number 8 says provide a curved arrow. So you can see that the hydroxide here, by penciling the lone pairs, the hydroxide is pulling the proton off of the hydrogen sulfur bond. So it's going to put the lone pair down here. So we end up with 3 lone pairs on the sulfur, 2 here. I guess I can put those ones in. So there's the curved arrows. So the thiol would be our acid. The hydroxide would be our base. This is our conjugate base, and this is our conjugate acid. And in the next one, it's the last one we'll do today, we have an aryl ammonium ion plus an amine, and we know that an amine is a stronger base than an aryl ammonium. And so if we pencil in our lone pairs here, this is going to attack the proton on the aryl ammonium ion, put a lone pair there. And so there you go. So this would be our acid, this would be our base, this would be our conjugate base, and this would be our conjugate acid. All right, so tomorrow morning, we're going to look at questions 10 through to, what's the last question, is number 24.